Okay, so extending on parallelograms. So first of all, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. Those are your 5 properties for all parallelograms, no matter what kind of parallelogram it is. Now, special parallelograms are going to have special properties depending on whether it is a rectangle, a square, or a rhombus. Okay? So starting with a rectangle. So a rectangle has opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and the diagonals bisect each other. But it has 2 more properties on top of those 5. So it has 7 properties total. The first one is that it has 4 right angles. And you guys already knew that, so that's not a new thing, okay? The next property is that the diagonals are congruent. So now my diagonals are congruent. So now when I go in here and I draw a line, so if I draw my diagonals now, not only do they bisect each other, but now all 4 pieces are congruent. So now that intersection in the center is now a midpoint for both diagonals. Okay, now we're going to hop over and do the rhombus. Okay, so now a rhombus has opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, the diagonals bisect each other. But it has 3 more additional properties that are not the same as the rectangle. Okay, so its properties are that it has 4 congruent sides. Now the diagonals bisect the angles. So not only do the diagonals bisect each other, now they're bisecting the angles. So now my diagonals bisect angles. And the last thing is that the diagonals are perpendicular to each other. So I'm going to put perpendicular. Remember the upside down T is perpendicular. So now, let me slide this over. If I were to draw my diagonals in here now, so now this piece is equal to this piece. This piece is equal to this piece. But now they're all right angles at the center. But now this piece is equal to this piece, and this piece. So remember, your opposite angles are equal, but now they got cut in half, so now you have 4 equal pieces. And this piece, this piece, this piece, and this piece. Now those 4 pieces are all equal. You still have the alternate interior angle and all that stuff going on, but now that the diagonals bisect the angles, it makes them a little easier. So now keep in mind, basically what happens is you've got these 4. Do y'all see the 4 right triangles that are inside the rhombus now? Well, all 4 of those right triangles are equal to each other. So if you know something about one of these right triangles, then you know all 4 of them. Okay? Now, cool thing is the square. The square is the combination of the rectangle and the rhombus. So not only is a square opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive angles supplementary, the diagonals bisect each other, but it has 4 right angles. It has 4 congruent sides. The diagonals are congruent, they're perpendicular, and they bisect angles. So it has all 10. But the 2 main ones are, well, if it'll write, 4 right angles, 4 congruent sides. So those are the 2 main things, but all the others are also true. So now if I draw my diagonals, it's perpendicular at the center, and all 4 pieces are equal. Now think about this. If my right angles in the corners get bisected, each piece is now 45. So basically now you have a bunch of 45, 45, 90s. So now every one of these little triangles are now 45, 45, 90s. So the whole x square root of 2 thing comes into play. Okay? So now those are the properties. So we are going to do some examples finding what's missing, and then you're going to get to practice all on your own. All right, so number 1. So number 1, go through, and again, I'm going to go through, find everything I can, and then go from there. So remember, so using our properties, number 1 is a rectangle. I think it got left off. So number 1 is a rectangle. So make sure you make note that this is a rectangle, because if you don't know what shape it is, then you don't know what properties it has. So I think the word rectangle, I think it might have got covered up by the image. So we know this is 10. We know this is 24. We also know that this is a right angle right here. So think about that for just a second. If this side is 10 and this side is 24, then can I do Pythagorean theorem to find the hypotenuse, which is the diagonal of the rectangle? So then I would see that PR is 10 squared plus 24 squared, and then take the square root. So 10 squared plus 24 squared, and then take the square root of that. We get that the whole thing, so PR is 26. Well, if PR is 26, so is SQ, because it's a rectangle and the diagonals just so happen to be the same size. But then don't forget that this is the midpoint. So now all 4 of these pieces get to be the same length. And if you take 26 and split it in half, you find out that all the pieces inside are 13. So QT is 13, SR is 24, because that's this side here, and QR is this side here, which is 10. So again, you're going to be doing your Pythagorean theorem, your special right triangles, trig, whatever you need to do. I could go as far as asking you to find the measure of this angle right here now. So if I wanted you to find, and we'll just do that just so you remember. So I could say find the angle of measure PRS. Because now if you're looking at that rectangle right there and you draw that just that piece of the triangle, this would be opposite and this would be adjacent, so I could use tangent to find the measure of that angle. Okay? So we would do the tangent of the angle that I'm looking for is equal to 10 over 24. So second tangent, 10 divided by 24. And I'm going to round to the nearest whole number to keep it simple, so that would be 23 degrees. So that angle would be 23 degrees. So if this angle right here is 23, then I know this angle up here is also 23. So is this one, and so is this one. Okay, and obviously they have to add up to 90, so 90 minus 23. So all of these would be 67. And then, of course, you would add and subtract from 180 and get those. So if I did 67 plus 67, subtracted from 180, I would get that this is 46, this is 46, 134, and 134. So depending on what it's actually asking you to find, it could give you minimal information, and you can still find it. Okay, because notice they only gave me 2 numbers, and we found a whole bunch more than 2 numbers. All right. All right. Scrolling over. This is a rhombus. Again, I think it got left off. So make note that this is a rhombus. And if I slid over before you got to write all the numbers, that's fine because I can slide back here in a minute, okay? So EF is 23. So EF is 23. Well, if EF is 23, so is DE, DG, and GF because it's a rhombus and all four sides are the same. Also, make sure as soon as you know that it's a rhombus that you go in here and put that your diagonals are perpendicular. That's super important that you have those four congruent right triangles at the center. I would also go in and put that these four angles are the same and these four angles are the same. Okay, just like parallelograms, if you know something, you know multiple things. It says that DF is 40. Well, if DF is 40, then that makes this piece 20 and this piece 20. And again, I can do Pythagorean theorem with just one of your triangles because you know two sides and find the piece, right? So if I do Pythagorean theorem to find that piece right there, then I know that EH is 23 squared minus 20 squared, and then take the square root. Because remember, if you know the hypotenuse of a right triangle, you're always going to subtract. So 23 squared minus 20 squared. It's 11.3578, so let's just go with 11.4. So we'll round to the nearest tenth. So this is 11.4, which means this is 11.4. So the whole thing would be 22.8. So EG would be 22.8. So GH is 11.4, HF is 20, and GF is 23. And again, if I wanted, I could do trig and find the measure of any angle if that's what they were asking. Okay, so do not forget about your sine, cosine, and tangent. All right, the next one says the diagonals of a rhombus. So I know the picture looks like a square. Do not judge by the way it looks, remember? So they're telling you that this is a rhombus. Therefore, if this angle is 44, so is this one, and this one. And don't forget that it's always 90 at the center. If this is 9, this is 9, 9, and 9. And if this angle is 90, then these two angles here, that one and that one, 44, and then the pink one there, have to add up to 90. So that would make all of these 46. If this diagonal part is 7, then this diagonal part is 7. Again, Pythagorean theorem, or you could do trig, either one now because you have this angle measure, and I could find the other piece here. If I wanted to find this one right here, then I could do Pythagorean theorem. So let's see if I can erase this piece here where I can see what that letter is. So if I wanted to find EB, then I would do Pythagorean theorem to find EB or DE, either one. Okay. So BC is 9. AC is this entire diagonal, so that would be 14. And then it says the measure of ADC, A to D to C. 46 and 46 is 92 degrees. So they didn't ask for that, but if they did, make sure that you're always doing Pythagorean theorem because you have right triangles. Or trig, because now you have those things. All right, the diagonals of rectangle EFGH intersect at I. So since it's a rectangle, automatically I know those four pieces are the same. There is no right angle at the center this time. That only applies to to rhombus and squares. But I do know that if this is 31, so is that piece, and that piece, which puts everything else at 59. So all of those, oops, this is 31 here. this piece right here is going to be 59 along with this. So what is the measure of angle FHG? So F to H to G would be this one right here. So we know that's 59 degrees because these two add up to 90 because it's a rectangle. HF, well, HF is this right here. So I'm going to have to do Pythagorean theorem to find that. If EG, oh, no, I'm not going to have to do that because EG is the other diagonal, and they told me that it was 17, which means both diagonals are the same. So if you know one, you know two. And then the last thing is EFH. E to F to H is that angle again, which is also 59 degrees. All right. Cool thing, squares. Guys, in a square, all your angles are either 90 at the center, 90 at the corners, or 45 once you draw the diagonals because they get bisected. So in a square, you got two choices. It's either 90 or 45. So that makes it a little bit simple. So we know that it's always going to be 90 here, and we know all the corners are 90. And then we know all these little pieces are going to be 45. I know that this piece, this piece, this piece, and this piece are all going to be 1/2. And I also know that all the sides are the same because it's a square. So let's find the length of PK. Well, the length of PK is the same as MK. And now the other two are angles. So what is the measure of PKN? PKN is 90. MNK is this piece here, so that would be 45. Please keep in mind, since this is a square with 45, 45, 90s, you know that 1/2 and 1/2 is 1. So if my my diagonal is 1, then I can find x, and this would be x square root of 2. So you could do that and go backwards. So we know that this whole thing is 1. So if x square root of 2 is equal to 1, then if we do x, remember you divide both sides by 2 and put the square root of 2. So this would be 1 divided by 2 square root 2, which would be what the length of the sides are. So these would be your sides if you want to make sure that you have that as a note. All right, so now let's just do some random examples just using the properties, not necessarily finding every single piece. So here they just want you to find the measure of ADE. Well, ADE is this angle right here, and I know that angle is equal to this. But we know both of these angles have to add up to 90. So I'm just going to add those two things together. So you've got 4x plus 13x, which is 17x, and 15 plus 7 is 22, and they have to add up to 90. So we got 90 minus 22 divided by 17. So x is 4, and then plug it back in. So 13 times 4 plus 7. So 59 degrees would be our final answer. All right, and the next one, it says it's a rectangle. So using the properties of a rectangle, we know that the diagonals are equal. And QS is a diagonal. and RT is a diagonal, so we know they're equal to each other. So I'm going to set QS and RT equal to each other. 5x minus 31 equals 2x plus 11. So subtract 2x, we get 3x. Add 31, we get 42. So 42 divided by 3, x is 14. And it said find the lengths of the diagonals. So once you find x, then just plug it in. So if I did 2 times 14 plus 11, that's 28 plus 11, which would be 39. So my diagonals are 39. This time we have a rhombus. What do we know about a rhombus? All the sides are equal. And that's the first property we want to go to because that's what the information is that they gave me. So set it equal. 9x minus 32 equals 5x plus 16. Subtract 5x, I get 4x. Add 32, I get 48. X is 12. And they want me to find PQ, which they're asking you for another side. The whole point is that you know the sides are the same. So 5 times 12 plus 16. 60 plus 16 is 76. Number 15, again, a rhombus. Remember that at the center, it's 90, which means these two angles here have to add up to 90. Okay, they will only be equal to each other if it is a square. Otherwise, they have to add up to 90. So you want to add these two together. So 7x plus 4x is 11x. 3 minus 1 is 2. They have to add up to 90. So 11x equals 88. X is 8. And then it says find the measure of HGI. HGI, which is this angle right here. So it's going to be equal to whatever 4x plus 3 is. So 4 times 8 plus 3 would be 35 degrees. Now in this one, it's rhombus again. So we know that it's 90 at the center. These two pieces, those are the two pieces that are equal to each other because the diagonal bisects the angle, so it means it cuts it in half. So now 13x minus 16 is equal to 9x plus 4. I know the algebra part is easy. It's knowing the properties. If you don't know the properties, then you're going to do the algebra wrong, even if you do the algebra correct with the wrong property. So you got to be real careful. So we subtract 9x, we get 4x. Add 16, we get 20. So x is 5. And they want me to find ADB, which is this angle over here. That angle over there and this angle here are the same, and we know these two have to add up to 90. So I'm going to plug x in, subtract it from 90. So 9 times 5 plus 4. So 9 times 5 is 45. 45 plus 4 is 49. So if this angle is 49, then the complement is 41. Because they have to add up to 90. Basic, simple, but again, if you use the wrong property on the wrong shape, it's going to get you the wrong answer, even if you do the algebra right. All right, last one's a square. Squares are my favorite because everything's 90 or 45. So we know it's 90 at the center. We know the main angles are 90, but we know all of these little pieces are all going to be 45. So that means that 6x minus 21 is 45. So 6x equals, add 21, we get 66. X is 11, and it just said solve for x. Done. nothing else to it.